Hello everyone. So in this video we continue with Chapter 6, Geometry and Trigonometry. This time with Section 6.2, Right-angled triangles and trigonometric functions of acute angles. So first of all, to clarify, acute means less than 90 degrees. Right-angled triangles. The conventional notation for triangles is to label the three vertices with capital letters. For example, capital A, B, and C. So we can see that here in figure 6.14 with the conventional triangle notation. So we have the vertices A, B, and C. The same capital letters can be used to represent the angles at these vertices. So we could talk about this angle as angle A. But we will often use a Greek letter such as alpha, beta, or theta instead, as we did in chapter 5. So we could use here instead of A, we could use beta. Not necessarily alpha. We can use either alpha, beta, or theta to represent any angle. The corresponding lowercase letters A, B, C represent the lengths of the sides opposite the vertices. So notice that lowercase a is the length of the side opposite angle capital A. The same thing for B and C. So, for example, B represents the length of the side opposite angle B, that is the line AC. So AC is opposite angle B. So in the following slide, you're going to find figure 6.17, which talks about angles of depression and elevation. An angle of elevation or depression is always measured from the horizontal. So that means that you have a line that is parallel to the ground, a horizontal. You have it here on the left for the angle of elevation, but also for the angle of depression, we need to have a horizontal. Also note that the angle of elevation from O to P is equal to the angle of depression from P to O. So what they're saying is that if this is theta from O to P, then if we did an angle of depression from P to O, first we need a horizontal. This would also be theta. Why is that? Well, because if you have two parallel lines and another line that is slanted crossing those parallel lines, you have what are called alternate interior angles that are equal. Notice that the same would be true for the case on the right-hand side. So if the angle of depression is alpha, so will be the angle of elevation from P to O. Okay, so now let's take a look at example 6.6, and it says, a man who is 183 centimeters tall casts a shadow 72 centimeters long on horizontal ground. What is the angle of elevation of the sun to the nearest tenth of a degree? So we need to find the value for this angle theta. Let's recall the trigonometric ratios. So sine of an angle alpha, or x, is equal to the opposite leg divided by the hypotenuse. Cosine is equal to, cosine of the angle is equal to the adjacent leg over the hypotenuse, and then tangent of an angle in the right angle triangle, of course, is equal to opposite leg over adjacent leg. So it is obvious that in this case we need to use tangent, because we know that tangent of theta is equal to 183 over 72. But since what they want us to find is the angle, we know that the angle is going to equal the inverse function of tangent of the ratio of 183 over 72. So for this, we're going to need the GDC. So if we go second tangent, we have the inverse tangent function. And it's going to be 183. So 183 divided by 72. We hit enter and we get 1.19, but that's in radians. So we have to make sure that our calculator is set for degrees. So we go to mode and notice that the third line says radian, but we need degrees. So hit enter there. And let's second mode, that's quit. It takes us back to that screen, and I just hit enter. And that gives us the measurement in degrees. So notice that that means that theta is approximately 68.5 degrees rounded to the nearest tenth of a degree. Let's continue with example 6.7, and it says, during a training exercise, an Air Force pilot is flying his jet at a constant altitude of 1,200 meters. His task is to fire a missile at a target on the ground. At the moment he fires his missile, he is able to see the target at an angle of depression of 18.5 degrees. If the missile travels in a straight line, what distance will the missile cover to the nearest meter from the jet to the target? Okay, so the first thing to remember here is that the angle of depression is equal to the angle of elevation. So that means that this angle here is also 18.5 degrees. So notice that in this case, we cannot use tangent because we don't have the adjacent side to the angle. But we have the opposite, which is 1,200 meters, and we need to find the hypotenuse. So we can use the function sine. So sine of 18.5 is going to equal opposite, so 1,200, over the hypotenuse, which in this case we represent with the letter x. And then all we have to do is send x to multiply. So x times sine of 18.5 is equal to 1,200. Therefore, x is equal to 1,200 divided by the sine of 18.5. So now let's plug this into the calculator. So we go 1,200 divided by sine of 18.5. Hit enter and we get 3,781.85435. Okay, but they want us to round to the nearest meter. So this means that this would be approximately 3,782 meters. We continue with example 6.8, and it says, a boat is sailing directly towards a cliff. The angle of elevation of a point on the top of the cliff and straight ahead of the boat increases from 10 degrees to 15 degrees as the ship sails a distance of 50 meters. Find the height of the cliff. So they want us to solve for h. Now notice that it's very interesting that by simply measuring the distance covered by the ship with the angle changing from 10 degrees to 15 degrees of elevation, we are able to calculate the height, in this case, of a cliff. This is going to require separating two triangles and solving a system of equations. So here we have separated the triangles representing the situations that we just described. So notice that for this first triangle, we can use the fact that tangent of 15 is equal to opposite over adjacent, so h over x. And for this other triangle, we have that tangent of 10 degrees is equal to h over x plus 50. So there's several ways to solve this, but we'll try to use the simplest one. So notice that we can rewrite this top equation as h equals x times tangent of 15. And we're going to use this to substitute in here and then solve for x. So tangent of 10 will now be equal to x times tangent of 15 over x plus 50. So we have two x's, so that means that we're going to have to multiply and then group, factor out, and all that stuff. So first of all, let's rewrite this as tangent of 10 times x plus 50 is equal to x times tangent of 15. And then let's distribute on the left-hand side. So we're going to get x times tangent of 10 plus 50 times tangent of 10 is equal to x times tangent of 15. And then we can rewrite this as 50 times tangent of 10 is equal to x times tangent 15 minus x tangent 10. So we can now factor out x from this expression to the right. So we can say 50 tangent 10 is equal to x times tangent of 15 minus tangent 10. And then finally we have that x is equal to 50 tangent 10 over tangent 15 minus tangent 10. Okay, one thing we don't want to do is to calculate this yet. You want to carry exact numbers until the very end, okay? Now, what do I mean by that? Well, we need to solve for h, not for x. But since h over here is equal to x times tangent of 15, and we have that x is equal to this expression that we just found, we can substitute again, but this time into the first equation. So h is going to equal 50 tangent 10 over tangent 15 minus tangent 10 times tangent of 15. Very well, so here we are with the GDC, and we have to find the expression that we wrote to the left here. So we would go parenthesis 50 tangent 10 divided by, and here we would need a parenthesis again, tangent of 15, so tangent 15 minus tangent 10. We close the bottom parenthesis, and then we close the first parenthesis. Now, the reason that we have to do it this way is that calculators basically will only do what you tell them to do. So notice that here we're doing first the expression on the left, so 50 times tangent of 10 divided by, and then it has to be divided by the whole expression. So that's why we need that other parenthesis. Otherwise, it will interpret it as you are dividing 50 tangent of 10 by tangent of 15 and then subtracting by tangent of 10. So this times tangent of 15, tangent 15. And then we hit enter. And we get 25.78. Now, because it doesn't specify rounding to any particular amount of decimals, we are expected then to round this to 3 significant figures. So h is equal to 25, or approximately, right? 25.8 meters to 3 significant figures. So next we're going to work on example 6.9, which will be the last one on this video. And it says, using a suitable right-angled triangle, find the exact minimum distance from the point 8, 3 to the line with the equation 2x minus y plus 2 is equal to 0. So there's several methods with which you can solve this problem. You can use the equation of the line and find this point here by finding another line that is perpendicular. Then we can use the distance formula to find that distance between the point and 8.3, which is d. Or we could use trigonometry with these angles, either one, and find d. Or we can do it with a different method, which is the one that you are expected to do in case this is a paper 1 question. So if this is where a paper 1 question, we cannot use calculators. Now, the first thing we need to do is find these side lengths. So the bottom one, notice that it starts for x at 1/2 and it stops at 8 in the second coordinate we see here. So that's 7.5, but 7.5 is the same as 15/2. So we can represent it in a fraction, 15/2. And then on the y-axis, it goes from 3 to 18. Therefore, there's a length of 15 here. So we're going to use Pythagoras to find the hypotenuse. So we know that that hypotenuse would be equal to 15 over 2 squared plus 15 squared, the square root of this. And then we're doing this manually with no calculator. So this is going to equal 225 fourths plus 225, and the square root of that. And then we need to simplify this. So we would go, this is equal to the square root of 225 plus 4 times 225. That's going to be 450 plus 450, so 900. And all of this divided by 4. And then we're going to get that this is equal to the square root of 1,125 over 4, which we can rewrite as the square root of 1,125 over 2. But we can simplify this further. We're going to do the prime factorization of 1,125. So let's do it over here. 1,125, and let's do the prime factorization. So it's not divisible by 2. So let's check if it's divisible by 3. So it's 5 plus 2, 7, plus 1, 8, plus 1, 9. So yes, it's divisible by 3. So we go 3 times 3 is 9. We're missing 2. 3 times 7 is 21. We're missing 1. 3 times 5 is 15. And then this number, if you add the digits, it's 15. Therefore, it's still divisible by 3. So let's divide by 3. 3 times 1. 3 times 2 is 6. We're missing 1. And 3 times 5 is 15. Now 125 is not divisible by 3 because if you add the digits, it gives you 8. But it is obviously divisible by 5. And it's 5 times 25, 5 times 5, and 5 times 1. So this is the prime factorization of 1125. So notice that we can rewrite this as 3 squared times 5 squared times 5. And if we were to do the square root of this, this is going to equal 3 times 5 times the square root of 5 or 15 square root of 5. So that means that this is equal to 15 square root of 5 over 2. Okay. Now that we have that length, so this is 15 square root of 5 over 2 expressed exactly. Notice that we can flip this triangle. We could flip it around. And if we flip it and we draw it this way, so this would be the right angle that we have on the bottom right, this one here. And this D would be a height. But now we have that the base is 15 square root of 5 over 2. And we have that these other two sides, this one would be 15 halves, and this one would be 15. So what we're going to do is use the fact that we can find the area of the yellow triangle, the whole thing, using two different ways. So if we use this triangle here, it's 1/2. So 1/2 base 15 square root of 5 over 2 over 2, 1/2 base times height. And the height here is D. Okay, so 1/2 times the base times the height. And that would equal, and that's by grabbing this as the base now. So 1/2 times 15 halves times 15, which is a height. And it is a height because this is a right angle. Just like D is a height here because this is also a right angle, right? It's perpendicular to the base. Okay, so now all we have to do is solve for D. So let's not multiply because we can cancel things out. Notice that we can cancel 1/2 with 1/2. And we can even cancel 15 halves. We can cancel 15 halves and 15 halves. Okay, this is not a 2 here. I made a mistake. This should read square root of 5, not 2. Sorry. So notice that we would be left only with square root of 5 times D is equal to 15. And then D is equal to 15 over the square root of 5. But you never want to answer with a radical or a root in the denominator. So we need to multiply this by square root of 5 over square root of 5, which is the same as multiplying by 1, but it gives us the advantage that we will be able to take this part out of the square root. So we have 15 square root of 5 divided by 5, and then finally we get that D is equal to 3 square root of 5.